Alrighty, here's video 3. We're looking to find the equation of the line that's tangent to the function. That should be a familiar phrase. When you see the equation of the line tangent to the function, we're really talking about this formula. And in order to use this formula, I need three things. I need an x-coordinate, which we have. I need the y-coordinate that produces, or the y-coordinate at which that x-coordinate is given. And then I need the slope, which means I need the derivative. So three things, and I have one of them. I have the x value. So this is 1/3. Awesome blossom. We also know that my formula always has this, and my formula always has this. So now all I need to do is figure out the y-coordinate. Okay, well, the y-coordinate is the function value. So f of 1/3 is the y-coordinate of tangent inverse of 3 times my x-coordinate, which is 1/3. Oh, but 3 times 1/3, that's 1. So really I'm looking for tangent inverse of 1. Y, by the way. So I'm looking to see where does that happen? Tangent inverse of 1. Or the other way to think about it, I suppose, would be the tangent of what angle is equal to 1? And there's an infinite number of angles, right? There's many answers to this, but we're going to go with the closest one to the unit circle. And so tangent, remember, is the y-coordinate of the x-coordinate, and that gives me 1. That means the x and the y have to be the same, exact same. So that's going to be at y equals pi over 4. That's the smallest angle where that can happen. It's also going to happen at 5 pi over 4, and then it'll happen again at 7 pi over 4. I'm sorry, not 7 pi over 4, 9 pi over 4, and so on and so on. But this is the smallest angle where it happens. The tangent of pi over 4 is 1, because that would be square root of 2 over 2 divided by square root of 2 over 2, which is equal to 1. But how did I know that? Well, I remember the unit circle. Number 2, I knew that this symbol meant this. I'm looking for the angle. That when I take the tangent of that angle, it equals 1. Great. Well, now I know my answer here. My answer here is pi over 4. So now the only thing that's missing is my slope. And in order to find slope, we need to find the derivative of this. So I come over here, and we're going to find the derivative of f. The derivative of tangent inverse, well, if we go back and look at our formulas, tangent inverse. The derivative of tangent inverse of something, that's what the u stands for, my inside function, something, is the derivative of that something divided by 1 plus that something squared. Alrighty? So it is the derivative of the something divided by 1 plus something squared, which is just going to give me 3 over 1 plus 9x squared. That's my derivative. That's what I'm looking for. Oh, except I want the derivative at 1/3. And at the beginning, you're thinking, oh my gosh, we're going to have to substitute a fraction into a function that's already a fraction. That's going to be terrible. Except, if I zoom in, and that's supposed to be a 3. Let me try to erase it here. And it's not erasing. Oh, there it erased. It erased again. It erased too much. 1 over 3, and all of this was under, yeah? Well, what's 1/3 squared? Because remember, order of operations say I have to do exponents before I multiply. So I have to do the squared before I multiply by 9. 1/3 squared. 1/3 squared is 1/3 times 1/3. So all of this becomes 1/9. Oh, what's 9 times 1/9? 9 times 1/9 is just 1. So this is 1. And therefore, when I add it to the other one, I get 3/2. I just figured out my slope. My slope is my derivative value, and I just figured out that the derivative value is 3/2. And so I have my equation of the tangent line created by, there you go, the three pieces of information: an x-coordinate, the y-coordinate that goes with that x-coordinate, and the slope of the tangent line. So I found my derivative, that's my slope. I used my original function to find my y because I was already given my x. This is the equation of the tangent line. What do we have to use? Oh, we had to use the formula for the equation of the tangent line, but also the derivative of tangent inverse.